We'll now look at some examples of using the fundamental theorem of calculus. So we'll start with finding the area under one bump of the sine curve. So if we think about this graph, we know that sine starts at 0, it comes up and goes back down. We know it hits the x-axis again at pi. So what we're going to look at is the integral from 0 to pi of sine of x. We know that the antiderivative of sine of x is negative cosine, because the integral of negative cosine is positive sine. And we're going to evaluate this between 0 and pi. So we start with our upper limit. Negative cosine pi minus negative cosine of 0. Cosine of pi is negative 1, so negative 1 is 1, plus cosine of 0 is 1. So the area under one bump of the sine curve is 2. Next, let's look at this. And in particular, we're going to concentrate on the interval from negative 2 to 3. And we want to find the net area. So first off, it might be nice to have some idea of what this graph looks like. And you can use lots of methods to do that, but it looks something like this, where this point's negative 2, and this is 3. So for the net area, we're just going to integrate between negative 2 and 3 of 2x, x plus 2, x minus 3. And it's very important before we integrate this that we multiply these things out. Integrals cannot be broken up across multiplication. And that multiplies to 2x cubed minus 2x squared minus 12x. When integrating polynomials, we add 1 to the exponent and divide by that number. So adding 1 to 3 is 4, and 2 over 4 is 1/2. This would be 2 over 3x cubed. And here, adding 1 to the exponent gives me x squared, and dividing by 2 is 6. And we're going to evaluate this between negative 2 and 3. Evaluating at 3, 1/2, 3 cubed is 81, minus 2/3, 3 cubed is 27, minus 6 times 3 squared, which is 9. Then we're going to subtract 1/2 times negative 2 to the 4th, which is positive 16, minus 2/3 times negative 2 cubed, which is negative 8, and then minus 6 times negative 2 squared, which is 4. And once you work all of this out, you get negative 125 over 6. And this is our net area. What the negative number means is that this area here on the right that's underneath the axis is going to be bigger than this area on the left, because we know this part gives us a positive area and this part gives us a negative. Let's do this again, once again between the interval of negative 2 to 3. And this time we want the total area. We had this graph before, and we know that on the left of the graph, in particular between negative 2 and 0, this thing was positive. And once we had multiplied out our function, we had 0, 2x cubed minus 2x squared minus 12x. Between 0 and 3, this function was negative, And if we want to make a negative number positive, we add this negative sign. So we'll have a double negative between 0 and 3 of, once again, 2x cubed minus 2x squared minus 12x dx. So now we'll integrate. Once again, this is 1/4 x to the 4th, or 1/2 x to the 4th. Fix that. Minus 2/3 x cubed minus 6x, going between -2 and 0, minus (1/2) x to the 4th minus 2/3 x cubed minus 6x squared, going between 0 and 3. This should be squared. Evaluating. The upper limit here gives us 0 minus 1/2 times -2 to the 4th, which is 16, minus 2/3 times -2 cubed, which is -8, minus 6 times -2 squared, which is 4. And then we're going to subtract out, evaluating at 3. So 1/4, 3 to the 4th is 81, or 1/2, 81. Minus 2/3, 3 cubed is 27, minus 6 times 3 squared, which is 9. And once you work all of this out, you get 253/6. We're going to look at one more example. In particular, the area under 2 minus the absolute value of x between -3 and 1. We know this is the interval from -3 to 1 of 2 minus the absolute value of x dx. The question is, how do we deal with this absolute value? Well, properties of absolute value says if x is greater than or equal to 0, the absolute value of x is equal to x. If x is less than 0, the absolute value of x is equal to -x. So we're going to have to break this up into two parts. We'll start with the negatives, -3 to 0. And since in this interval we are negative, we're in the second case where the absolute value of x is -x. So -x is plus x. The second half of this interval is going to be between 0 and 1. And in the positive case, the absolute value of x is just x. So here we have 2x plus 1/2 x squared between -3 and 0, plus 2x minus 1/2 x squared between 0 and 1. When I stick in 0, I get 0 minus 2 times -3. Plus 1/2, -3 squared is 9. Plus 2 times 1, minus 1/2, 1 squared, minus sticking in the lower limit, which is 0. And once you work all of this out, you get an area of 3.